Let's look at the equilibrium constant K again. Equilibrium constant. It means for a chemical reaction, it is the value of reaction quotient when that reaction reaches equilibrium. Its reaction quotient, but when it reaches equilibrium, when the forward reaction rate is the same as the reverse reaction rate, when there's no net change in the species concentration or quantity over time, then equilibrium constant would be independent. It would be independent of the actual concentration of the reactant or product species. It's independent of the exact reactant or product species concentration, but this value, this equilibrium constant value, depends on temperature, pressure, and of course the specific system. And for a general chemical reaction, we say alpha A plus beta B to form gamma C and delta D. For this general reaction, the equilibrium constant would be this symbol for product. For product of all the different reaction products, the activity raised to the power of stoichiometric coefficient divided by the product for all the reactants activity, but each raised to the power of also for that species stoichiometric coefficient. So for this specific example, of course it is under equilibrium condition. For this specific example, it will be activity for product C raised to the power of gamma times activity for product D raised to the power of delta. This would be for the total numerator, the products for all the products, divided by, for denominator, activity for reactant A raised to the power of alpha times activity for product B raised to the power of beta. So this gives us the reaction quotient, and if it's under equilibrium condition, then the reaction quotient would give us so-called the equilibrium constant. Okay, that's what you learned in chemistry. And then let's look at the relationship between delta G0, free energy change under standard state, E0 standard cell potential, and K equilibrium constant. We have a triangle, okay, a relationship between these three parameters. Between delta G0, standard free energy change, and equilibrium constant, we have this relationship. Delta G0 equals minus RT ln K. Or put another way, the reaction free energy change would be delta G0 plus RT ln K, and under equilibrium that should be 0, so as a result, delta G0 would be minus RT ln K. Similarly, between delta G0 and E cell 0, that will be the conservation of energy, the electrical power, the electrical energy, which is NFE0, would be equal to the absolute value of the change in free energy. Okay, that and the free energy change for a process quite often is negative, which means free energy decrease, and then that energy would be used to as work done to the outside. So the work is positive, the negative for the other G0, so we have negative sign here. So finally, between E0, the standard cell potential, and the reaction equilibrium constant, we have this relationship. Okay, and when the standard cell potential is 0, there will be no reaction, no net reaction, which means the equilibrium constant would be 1. And these are the signs and what they mean by in terms of direction of reaction. As we said earlier, if a reaction is spontaneous in the forward direction, it requires the free energy change to be negative, which means the system energy decrease. But it also requires the standard cell potential to be positive, means it can do work through the external circuit to the environment. And it also means the equilibrium constant would be greater than 1 under standard condition. On the other hand, if the delta G0 is positive, or the cell potential is negative, or the equilibrium constant is smaller than 1, that means the forward reaction is not spontaneous, is energetically forbidden, but the reverse reaction would be spontaneous, would be energetically favorable. And finally, if delta G0 is 0, the system is at equilibrium. There will be no net reaction. It would be the same as if the standard cell potential is 0. No electrical work can be done. The system is also at equilibrium. And the implication for K would be under that condition, K would be equal to 1, as what you can see here. Okay?